All right, so this is our bit here, and then our nearly last question. We need to go through those, and then we have the bit. So this is a statistic question. We have K here, and then so all of them should be add up equals to 1. So K will be equal to 1 minus 0.89, then 98 minus 0.01 equals to 0.01. And then because of that, we need to find the mean. Because these two are identical, so we need to find that. So we only have to have 93 plus 119 divided by 2. Calculator. So 93 plus 119 divided by 2 is 106. All right. So when we need to find this, and this is 5 points, so we need to do a bit more. So now we need to find it for probability of 93. Oh no, we need to do it one side. So we have probability of x of m smaller than 119 is equals to 0.99. Yeah. So we do not have the mean, so we need to do something to find the mean and the standard D too. So yeah, do we have the mean? Yeah, we have the mean. You need the standard D to find the next step. So what you need to do is like we use the z-score. So 119 minus the mean 106 times the standard D should be equals to. Now here we go. Statistics. We don't need to care about those. We go to distribution. Ours is normal distribution, and we want to inverse. So now we want it to be smaller, so it is the left. Make sure the data is variable, not the list, because you're using the list is wrong. So it's the left, and from the left onward, from left side onward, is 0.99. All right. We do not know either of them, so we will stick with the standard D1 and the mean 0. That gives you 2.326,34787. Exciting. So what you need to do is we throw it to the other side and we find it. So get back to that. We got 119 minus 106. That should be 13 equals to 2.326,34787. It's a bit annoying now. So we get through those. Calculator again. So we have 13 divided by 2.326,34787. All right, and then we get our standard D, our standard D to be 5.58815. I will leave a bit more. Now with those, I would be able to find it. So now we have our bit, our M normally distributed with mean is 106 and the standard D is 5.5881 square. All right, because it's the mean and the variance. If you want to use the notation, make sure it's the mean and the notation. Now we need to find 95. So now we're going to do it. Manual, statistics, normal distribution, normal distribution. Because it's smaller than 95, so we have to. So the lower bit could be any number, relieve some stress, negative, 9999, very small number. And then the upper, we could accept is up to 95. This time we got our standard D, 5.58815, and then our mean is 106. Zoom, and then we got our answer, 0.245. Remember, 3 significant figure, we don't count the 0 in front, we count the bit start from here, so 1, 2, 3. I know you know what, just let me say it. All right, moving on, we have 6 apples in a bag, and then it's a 10. So we want the mass less than this, so we now become, with a sample, we need a certain bit of those. So we have our GDC again, this time it's a normal distribution. So, now we have our Y, which is a binomial distribution with 10 trial, and the probability is 0.0245. All right, probability, the trial, the probability. I want to be at most 1, so it's probability x smaller than 1, which actually become probability of x equals to 0. True, because there's only 1. We do not have at most, no, at most 1 is included, sorry. So we're going to use our GDC with it because they are so powerful. So this time we go back to distribution, binomial, and inclusive at most 1. So from 0 to 1 at 10 trial, and then the probability is 0.0245. And then our probability is 0.976, pretty high. All right. Now moving on, we'll find now we contain 50 bags of apple, and then we take in a crate at most 1 apple. So it's a small apple. So now it's getting annoying with that. It's like we need to get through those, and then we have the bit of it. So we'll have the. All right, getting into the expected value, the crate needs 50 bags of it at most 1. So it's the same way. So we have 50 times 0.976 to get the expected value of y here. So now we have 50. Get back to our manual, the normal calculation. 50 times 0.976. Now I got 48.8. Last but not least, we want to probably at least 48 back, and then we have at least 1 per. So now become another probability here. So we have probability of a binomial distribution B with 50 bags, sample, and the probability 9.76. So this time we want the bags should be bigger than 48. Now we use our calculator again, manual, statistics, distribution, binomial. This time we have bigger up to 48. So we have up to 48 from 0 onwards, 50 bags, and then the probability is 0.876. And this is sorry, I need to know. At least 48. Sorry, it's lower is 48. Upper is 50. Yeah, and that's our answer there. So at least 48. So careful with that. And then the probability should be 0.882 as request. And this is our answer.